Hello my friends, welcome to Code Guy channel. In this workshop we will build a linked list. First step, define class linked list and put path in the body of this class. Step number 2, define class node inside the linked list class and put path in the body of node class. Step number 3, node init class should accept self and element. Assign element to self element. Step 4, during the initialization, self next supposed to be assigned to none. Step 5, define init method for linked list itself. Self length supposed to be assigned to 0. Step 6, class linked list supposed to have self head assigned to none. Step 7, linked list will have is empty method. The method will accept self and check if self length is 0. Step 8, here we are creating our first instance, myList, and assign to the class linked list. And then we are printing the result of calling method is empty on myList instance. Step 9, define method add that will accept self and element. Inside the body of this method, define node variable. That will be an instance of node class and element passing as a parameter. If linked list is empty, this element is supposed to become the head. Create if statement. If is empty method will return the truth, self head become the node. Step 11, create else statement. If the list is not empty, we will create the variable current node and assign it to the self head. Step 12, in the while loop, when current node next is not none, current node is assigned to current node next. Step 13, outside of the else block, right after while block, assign node to the current node next. Step 14, outside of if-else statement, increase self length by 1. Step 15, to test our functionality, call add method on myList with 1 and 2. Then print myList is empty method and myList length. Step 16, start to create a remove method. Pass self and element as parameters. Inside the body of the method, create a previous node variable and assign none to it. Step 17, we need to figure out which element to remove, so create current node variable and assign it to the self head. Step 18, now we need to loop through the linked list to find the node that contains the specific element to remove. Create while loop where current node is not none and current node element not equal element. In the body of the while loop, put previous node equals current node. Step 19, to move current node pointer to the next node, assign current node next to the current node in the while loop. Step 20, when current node is none, then we find the element that we need to remove and function needs to stop executing, so put return in the body of if statement. Step 21, here we will be updating the next pointer for the previous node. Else if previous node is not none, previous node next equal to current node next. Step 22, if the element that we are removing is self head, then we need to update it as well. Create an else statement and assign current node next to the self head. Step 23, now we need to change self length by decreasing it by 1. Step 24, the final thing we need to do is to check how remove method is working, so write mylist.remove1 and add print statement mylist length. We are done. I hope it was helpful for you. Thank you for watching. Bye bye.